All right, this is AP Calculus, lesson 5-5, trigonometric antiderivatives. Today's date is Monday, December 7th, 2020. Our objective today, Chris, is to Are you there, Chris? Okay, Andrea?
Find the antiderivative of functions that would be in the trig house.
Exactly, yeah, so it's all the trigs. So let's just review the houses that we already know. We know general house and power house. So general house just has an F usually in it. Fiona, what's the antiderivative of this general house?
A over AF double prime.
So if I take the derivative again, I get another prime. But if I'm going backwards of a forwards, they kind of cancel each other out. Oh, sorry, say it again.
AF.
AF, yeah. AF of whatever. And then don't forget your plus C. Yeah, or cake. Nice. Teflon, do powerhouse. You, of course, have that A still out in front. This is going to be something to the power of what now?
N plus 1.
Plus 1. And then what do I do with that N plus 1?
Divide down.
Divide down. So divide by N plus, that's about plus 1. And don't forget your
Plus C.
Plus C. There it is. All right. So those rules are the easier ones. Let's try about the ones we just learned on Friday. So this one, whenever I have to the power of -1, and Chris, are you there? You are, I see you. What is this one? When I have anything to the power of -1 and I take the antiderivative?
Is it a natural log?
A, yeah, natural log of, is it parentheses or absolute value?
Absolute value.
Perfect, yeah, absolute value of whatever's on the inside. And don't forget your
plus C.
Plus C, there it is. And then Andrea, antiderivative of this one.
Was it just the same?
Just the same, yep. But
plus C.
Plus C, yeah. Don't forget your cake. You always have to remember that cake. Perfect. So those are the 4 houses that we've gone over. We've talked about general house, power house, natural log house, or just log house, and E house. Cool. Good job, guys. All right. And then use substitution, or I guess what we've been using for taxman. I should put that up here, taxman. So use substitution or use taxman. And the general rule of thumb is just always use it and you'll never be wrong because it works even when you don't need to use it as well. So, but when do you have to use it? Let's give that to Fiona.
When do I have to use which one?
Taxman, use substitution, either one. Like you have to use something extra whenever
You're taking an antiderivative?
I mean, in general, yes, but for example, the antiderivative of x, I don't need to use taxman. I just know, oh yeah, that's x squared over 2. So I didn't need to use taxman here. I mean, you can always use it. And again, I agree, you should just always use it if you don't know what to do. But there's a specific case when you have to use it. Do you remember when that is? I'm getting a blank stare. Anyone else? When do you have to use taxman? When do you have to use substitution? And I will give this to us. It's whenever the inner derivative. So whenever your derivative of the inner is not equal to 1. So in this basic case that I was talking to Fiona about, the antiderivative of x, well, the inner here is x, therefore dinner is 1. So I didn't need to use taxman because dinner was 1. Anytime that I have something like the antiderivative of like 2x to the power of 2, well, now the inner here is 2x and the derivative of that is 2. I have to use taxman for this type of problem. All right, so there is our review. Now we can start learning our new stuff. And I should really say that that should be on the speed sheet, but I haven't printed out the speed sheet for you guys. So this is like literally all of these 5 are the first 5 entries on your speed sheet. All right, let's go forwards. When I take the derivative of sine, what do I get, Teflon?
Cosine?
Cosine of blah. Okay, good. Andrea, derivative of cosine?
Negative sign.
Negative sine, perfect. Chris, derivative of tangent?
Secant squared.
Good job. Yep, secant squared of whatever. And again, everyone remembers that this is really the same thing as secant of that thing, and then all of this thing to the power of 2. Whenever I have a 2 right here, it just means that's the first thing I do. It's just a shorthand way of writing that. All right, so, and then going backwards. So our mnemonic to remember the signs was S stands for same. So if it was a positive, it stays a positive, and C stands for change it to a negative. Anti means to the opposite. So anti-same means change. This is going to change signs to a negative. And I have a cosine of theta. The main thing that you have to remember about all your sines and cosines, is they just flip-flop between each other. Sine goes to cosine goes to sine. The only hard part is it negative or is it not? And again, this answer is it is negative because it's an anti-same. Anti-same means change to a negative. Therefore, anti of cosine change, what is this next one going to be, Fiona?
Negative a sine.
Negative a sine. Not quite, because anti-change means don't change, right?
Never mind, it's not like that.
Yeah, exactly. Yeah, not negative. It's just the sign. And then you can check this, of course, right? If you take the derivative of negative cosine, well, cosine stands for change. You change that again, you'd have a double negative, and it would go back into a positive sign. So it makes sense if we checked our work. And then obviously, if I see a secant squared, Teflon, the antiderivative there would be
Would it be secant to the power of 1?
not quite. So if you see this and we were trying to go backwards, right?
Tangent?
Exactly, not just tangent. So you still have to have that a out front too. So a tangent of whatever. And then we've all forgotten our cake. So let me add that in here. Plus c, plus c, plus c. Okay. And I can write this down like the mnemonic for this one was anti-same, which is the same thing as saying a change. Nice, nice. All right, let's try example number 1. So I have to do taxman. Just always assume you have to do taxman. You'll never get it wrong. So for taxman, Andrea, what are the 3 things that we need and what are they?
It's U, taxman, and U prime.
U, taxman, and U prime. What are they?
U is 5 sine.
U, not quite.
Oh, 10x.
There you go. 10x. Keep going.
And taxman is 5 sine. And then U prime is 10.
Perfect. Thank you. And then Chris, what are we going to pay taxman?
Half.
Half, exactly. Yeah. So 5 over 10 reduces to 1 over 2, 1/2. So this 5 is going to be paid out with the 1/2, and then rewrite everything else. So we have sine of 10x dx. We have paid taxman. We are now given permission to take the antiderivative. Fiona, you're up.
Negative 1/2 sine of 10x plus c.
Good job. Yeah, plus C. Final answer and box it. Good job, guys. We have one more
Wait,
problem on the back.
Actually, it's actually cosine.
Oh, I did not even catch that. I was just paying attention to the negative. Yeah, good job. It should be a cosine. It always flip-flops. Good catch. All right, questions on the front before we go to the final problem on the back? Looks like we're all okay. All right, example number 2. Ooh, I have a negative 1/3 out front. How is that going to change things? Well, let's see. So Teflon, we have 3 things to set this up because just always assuming you have to do taxman, you'll never get it wrong. In this case, you definitely need taxman because the inner here is 4x, therefore dinner is 4. Dinner is not 1, it's 4. We need taxman. What are the 3 things?
Is it negative 1/3?
What is negative 1/3?
Oh wait, you're asking for all the steps?
Oh yeah, all the steps for taxman, please.
Oh, u is 4x. Taxman is negative 1/3. And then u prime is 4.
There it is, yeah. And it's important that even though taxman is outside, I guess, really outside, knocking on the front door, it's still in front of, so it is that taxman. Good job. Then we're giving it up to Andrea. What are we paying taxman? It's a little bit harder now. We have fractions.
Would be negative 1/12.
Exactly, yeah. How'd you get that?
I kept it and I keep it, change it, flip it.
So kept the negative 1/3, change it to a multiplication problem instead of a division problem. And 4, the reciprocal of 4 is just 1/4. And again, I agree, negative 1/12 is how we pay taxman. Cool, so let's go ahead and rewrite our integral. And it doesn't matter if this negative 1/12 is inside or outside. We can leave it outside, it doesn't matter, sure. Negative 1/12 integral of cosine of 4x dx. And then Chris, you are up. Take the antiderivative.
Negative 1/12 sine.
Sine of 4x, and don't forget your
Plus C.
plus C. Perfect. Cool. That is our final answer. We'll box it. I'll write down the rule that I used up here because I didn't make it explicit enough. If ever I have a number, I don't know, let me just choose 7, a random number. If I have 7 integral of something, I'm just going to leave it a box, dx. This is mathematically equivalent to the integral of 7 of that box, dx, which is just a fancy way of this 7 is allowed to go to the outside. It's allowed to go back to the inside. It doesn't matter where that 7 goes as long as it's just being multiplied by the integral. It can go in or out.
Wouldn't the answer be positive?
Ooh, anti-change. I think it's negative, right? Because this is, whenever I'm doing antiderivative of cosine, anti-change means same. It should be the same sign, should still be a negative.
Oh, okay, never mind.
Yeah, good question. I don't know, and this is where we finally start getting confusing because the rules were super straightforward before, but now we're going backwards and stuff, so it does get harder. All right, so that's what our notes look like in all of them, or for everything. Questions? Yeah, okay, then fist of 5. How well can you find the antiderivative of functions that will be in trig house? 4 for Fiona, 4 for Teflon, 4 for Andrea, 4 for Chris. All right, thank you.